So, hi everyone. Hopefully you are in the right room. This is leverage event-driven Ansible to reduce your automation reaction time. So today we'll be talking a little bit about how EDA or event-driven automation Ansible can help you. How does EDA work? And then some takeaways. So very briefly about me, I have been working in IT for the last 20 odd years, and mostly in operation kind of roles. So I am a sysadmin first kind of person, and I have been using Ansible for the last 11, 12 years and now. And I have written books on it and other things as well. And now I am an associate principal special solution architect for Ansible at Red Hat, which basically means that I help big customers and partners to leverage our technology without shooting themselves into the foot. And a couple of disclaimers about this presentation. Everything we are going to discuss today is fully open source, and it's exactly the same if you are using the community version or the enterprise version, and everything works exactly the same. So I want to start telling you a little bit of a story. This was before my Red Hat days. So I was a freelance consultant at a customer, and basically I had a huge down of their ERP system. And this was especially bad because they are a seasonal business, so basically Christmas is very important for them. And this happened 20 days before Christmas, which means bad for the business. So I got asked to understand what happened, what went wrong, and how to improve that situation. So just to give you a little bit of an idea of what the analysis came out to be, obviously there was the ERP going down. That's the first step. The person, on-call person, received the notice about this. They decided that this was a little bit too complex for them or too risky for them because it's a critical system. So they decided to open a ticket. The ticket got assigned to the ERP team, and someone actually acted on it. And the way they acted was removing a few files from a server and restart ADB. And then the ERP went back up. Okay? How many people can relate to those kind of operations that happen when something goes down? Okay, a few. So how many people think that from the red box to the green box elapsed less than 3 hours? No one? Okay. Less than 6? 1, 2? More than 6? A few? Okay, so most of you were correct because it was 6 hours, 18 minutes. So it was roughly 6 hours. And I think the interesting part is that obviously the only value added step was this one, the part where actually someone did something and fixed the problem. And how long do you think that step actually was timed to? Any idea? 20 minutes? 5 minutes? Very close. 4 minutes, 57 seconds. And which I think it's very interesting, because if a sysadmin wake up in the middle of the night, and in less than 5 minutes from when he starts to do something, he fixes an issue, that's kind of a signal that he knew exactly what to do. And there is a reason for that. In the previous 6 months, the same issue happened 8 times. Now, no one cared because it was not business critical season. I mean, everyone noticed it, but who cares? And this is a very interesting situation because this happens in every single company, every single day. So I think there is a very important aspect to this, because if you can automate this whole part before this actually would have been a 5 minutes down occasion, and probably no one really cared about 5 minutes in the middle of the night, or the impact would have been way less. So this is where event-driven automation can help. And the way Ansible, Event-Driven Ansible does this is with the logic that starts with an event gets received by the EDA tool. There is then a decision made on the event. Basically, is this an event that we already know and know how to fix? And if so, simply run the required automation to actually resolve the issue. And all of this obviously is across domain, across vendor and so on, because we are still leveraging the Ansible automation itself. So this means that everything that you can do with Ansible, you can also do it with EDA. And just to give you a little bit of context about the advantages, the first one is that it's flexible due to this dependency on Ansible code. This means that we have all that Ansible knowledge and integrations that we can reuse into those kind of systems. It's IT friendly due to that huge body of integrations that we already have, as well as it's designed to be scalable and robust. And also, due to that high level of integration that we already have, this means that it can become the single automation platform for in managing those kind of events, because obviously there are many other tools similar to this, but some of those are like only for networking situations or only for specific clouds and so on, which means that if you are a multi-cloud situation or hybrid cloud situation, you then will have to handle maybe 2 or 5, 10, 20 of those systems, which kind of defeat the point. So a few common use cases, those are absolutely not a complete list. You can use it for whatever you want, but those are common situations, such as, for instance, resource limits events, like in the previous case, that was a disk pressure issue, but you can have other kind of issues. Also in the cloud, for instance, you can scale with these systems. Obviously, clouds also have usually their own ways of handling scaling, but those ways are sometimes not enough or not very specific to your workload. And also a very interesting use I found is the log enrichment one, which basically is a situation where you have an event, so something went down basically, and or maybe something did not went down, but something happened at least. And with EDA, you get additional information that you add to the ticket. So that basically the person that will handle the ticket already sees the issue and then a bunch of context that will help him or her understand more quickly the situation and therefore react. So how does EDA works? The logic is fairly straightforward. We have sources, rules, and actions. As for sources, we have a lot of sources already available. In reality, you can bring your own source. It's enough to create a Python program or whatever programming language you prefer to simply transform those events into calls, Python calls. And an example on how a source gets used is this one. This is the webhook. So effectively, you expose a webhook, and it's 4 lines of YAML code, and you have a webhook available to be called from whatever system you're using. And those events that get sourced from the source then go through a bunch of filters. And those filters help you to better refine those events. We do provide a couple of filters, such as JSON filter and dashes to underscore filters. Also, we always, by default at least, put insert meta info filter, which allows Ansible EDA to add additional context from the source event to the event within Ansible itself. But then obviously filters can be chained, and you can write your own filters if you have specific needs. And an example on how this looks from a usage perspective is this. So very easily. We list a bunch of filters, and some filters will have parameters and so on. And this is for the sources part. So with those two tools, we can source and filter and improve the structure of events so that they are then useful for our rules. So from the rules perspective, EDA uses rules to determine what action it should take. It can have a single condition. Every rule can have a single condition or multiple conditions. And it can have one or more actions associated to it. And just to give you some examples, rule conditions, it can use the received event for the rule itself. It can also look at previous events that happen in the same rule, and also variables and other things that can be stored throughout runs. And a condition can contain one or multiple sub-conditions, and those can be with and or ors, basically. And we support the majority of most common used types, so integer, strings, bools, floats, so on. And also, it's possible to set facts and events from rules, which means that you can have a rule that sets an event, creates an event, basically, that then triggers another rule or another set of rules, if that's required for the usage that you are doing about this. And rules, actions, so the other part of the rule. In rules, we have conditions and actions, so the action part. This is simple YAML, and it can be of many kind. So it can be a playbook, an Ansible playbook to be run, or it can be a template, module, a single module, or a bunch of other things. So that basically you can do whatever you want. I mean, in theory, already with just the run playbook, you can do whatever you want. But you know, there are some cases such as shutdowns, which it's a little bit complex to write an effective playbook to handle shutdowns, because you have to do the shutdown, then wait, and then ping until it comes back up. So we have pre-scripted it so that you can avoid having to write it your own. And to give you a couple of examples on how those looks like, this is a simple one where basically we have a simple condition. Let's say that the event has an outage variable. If the outage variable is equal to true, then we are going to execute that playbook. Also, it can be a little bit more complex than that. And this is a different case where we have a couple of conditions and then a couple of actions. But as you can see, it's fairly straightforward from a syntax point of view. So there is an aspect that I think it's very interesting, which is rules throttling, because there are cases where you don't care if an event actually happens once, but you want to know the frequency of those events, or act one time and then not act for a bunch of time, because you don't want to continuously fire actions before the first action actually got completed and the results can be appreciated. So we can group events, and this can be done in two ways. One is to act on the first event within a time frame, and then not act for the rest of the time frame, no matter how many times the event happens again. Or we can collect all the data about all the events that happen within a time frame and then act at the end of the time frame based on the number of actions we have. And then we have many different units for those time frames, so that basically it can be milliseconds if it's a very real-time thing, or it can be days. So a couple of examples. This one is about a reactive one, so of the first kind. So it will run the notify outage playbook the first time the event happens, and then for 5 minutes it will not care about the same event happening again, so that basically you don't ping your people 50 times in 5 minutes, because they will still need 5 minutes to react. Or this case is the opposite, which is it runs once after 5 minutes, and then it will know the number of times that it got fired. So now we have those rules that have condition and actions. We put them together in rule sets, and basically rule sets are a set, as the name suggests, of rules. Every rule set has a name, define event sources, host, and rules, obviously. But the interesting part is that every rule set runs completely independently from every other rule set that you have configured. So effectively, you can have those completely different parts of this event-driven system that don't interact with one of the other. Even though rule set can post events, which means that if a rule set posts an event that then gets catched by another rule set, then obviously you can also have interactions there, but you have to do it yourself. It does not make it automatically. So an example of a rule set, this is a functioning rule set. You would have at least one source. Maybe you have some filters, and then you have at least one rule. Very straightforward, I think. And obviously, you can then put multiple rule sets in rule books so that you can have a higher level abstraction for those kind of concepts. And rule books is, as you can imagine, this is the first rule set that we have just seen in the previous slide, and this is the second rule set, which has its own source and his own rules. So some takeaways. The first one is that triggering automation from events can reduce the outage time or any intervention time, because obviously you remove all the humans process of figuring out that something happened and then should I do? Should I try to fix it? Should I escalate this or whatever? And Event-Driven Ansible allows to trigger Ansible automation from a lot of different sources, which means that maybe you have one single playbook that runs and fixes a certain kind of issues, but then you have multiple sources that can trigger that playbook, because maybe you have different points of your infrastructure where you can detect that kind of issue. And also, EDA is featureful, but very simple to implement, because as you have seen in 10, 15 lines of YAML code, you can have a running rule set or rule book. So with this, we can move to Q&A if there are questions. Yeah?
So where are these Ansible playbooks or events expected to run? What receives the events and then executes something?
Okay, so the question is, what receives those events and then execute the Ansible code? So it's called EDA server. We are not very creative with names. It's basically a daemon that will run wherever you want. You can run it in a container, you can run in a VM or whatever else. And it will either listen on ports, such as with the webhook source example, or in other cases, it can subscribe to event sources. So for instance, if you are using a Kafka event stream, then that EDA server will hook into the Kafka queue as a consumer, so that basically can consume those events. And then it will be that EDA server to run the Ansible automation. Thank you. Yep.
Do you have any kind of code example for a real case of this usage, for example, on GitHub or something?
Yes. If you look, there are two repositories for EDA. One is called EDA server, the other one is called EDA. In the EDA one, you will find examples of playbooks and full rule books and so on for some cases. So it's not like, probably it will not work exactly properly in your infrastructure, because your infrastructure is not a generic one, but is your specific one, but you can be inspired by those. And In which GitHub it is, it's Ansible/EDA. GitHub.com/Ansible/EDA, and then GitHub.com/Ansible/EDA -server.
Hi. Is there any way for, let's say, something like Opsgenie to send web-app events to this EDA server in a secure and proven way? Or do I need to figure out how to do authentication and authorization myself?
So the question is about Opsgenie, if it can be integrated. And I don't have a specific answer to that. But what I can tell you is that as long as he is able to produce one of those kind of events, then you can easily consume it, or you can write a simple script to, hook the one kind of event to another, basically. Other questions? Yep. So the question is, if you have multiple Kubernetes deployments, would you run one EDA per deployment, or maybe one for everything? I would say it really depends. So if your Kubernetes deployments are completely independent one from the other, let's say, for instance, that you have one Kubernetes per customer, whatever that per customer means, then maybe it can be a good strategy. If, in the other hand, those are different systems that interact together, then probably it's better to have one single EDA that rules them all. Also, if you have one EDA that rules them all, you have the advantage that you can do cross-cluster things. I mean, in theory, you can do it even if you have 50 different EDAs, but it would become very complex very, very soon. The downside of having one EDA is that for whatever reason that EDA goes down, then or maybe you lose connectivity to it, then it will not be able to act as you expect. But that's, I think, a little bit the trade-off of every single one versus multi situation. Yep. So how about using this in AWX? AWX is the community version of Ansible Automation Platform. This is absolutely doable. You will need to have a different daemon because EDA server is a different daemon from the AWX server. But actually, that's the same also in the enterprise version. It's simply branded differently. But in the end, it's like you will have two daemons. One is AWX, and the other one would be the EDA server. One more? Okay, I think we don't have it. Thank you.